Good evening, everyone, and welcome to E2E Network's webinar on building AI-powered applications with Langchain with Juan Peredo. I'm Uzma, and I'll be your host for today. This webinar is brought to you by E2E Networks Limited, India's leading cloud GPU provider. Let me now take a moment to introduce you to our speaker for today, Juan Peredo. Juan is an experienced independent cloud application architect with a rich background in technology, application design, and development. He has helped numerous companies modernize their operations while working at companies like AWS. His interests include AI-based applications, infrastructure as code, containers, and enhancing tech teams' work-life balance through automation. He enjoys sharing his extensive knowledge by speaking at conferences and meetups and webinars such as ours. So now on to the main event. Juan, over to you now.
Awesome. Thank you very much for that. I appreciate it. Let me start by sharing my screen. Let me know when you can see my screen.
Yeah, we can see it.
Awesome. Welcome, everybody. Let me move screen a little bit to the side here. So just so that everybody knows, I have two screens to monitor. So if I see me looking at the other monitor, it's not that I'm not paying attention. I'm just looking at my other side here. All right. So welcome, everybody, to building AI-powered applications with Langchain. And let's get started. So, as mentioned before, my name is Juan Peredo. I'll be your guide through this journey. I won't go much into my details since we had such a nice introduction at the beginning. And instead, we're gonna jump right in. So what is Langchain, right? For those that never heard of it or never used it, Langchain is a framework that allows you to build AI-based applications quicker, faster, and more reliably. And it aims to do so from the very beginning, from application creation all the way to monitoring and traceability. So it has different modules that will allow you to work with these large language models that are, at the end of the day, black boxes that introduce a lot of randomness into your application, right? Unlike the code that we're used to write normally, we usually have very deterministic answers to different things, right? With an LLM, you never know what the LLM is, how the LLM is going to reply, or what type of questions somebody's going to ask. So it's very important to not only create a reliable application, but also to trace the application to understand how the LLM is interacting with the user, whether we're providing the correct answers, whether we're having some hallucinations, and whether our users are happy. And Langchain has four main modules: LangServe, Langchain, LangSmith, and LangGraph. We're going to be talking about three of them in this particular talk. Starting with LangServe. And LangServe basically allows you to create the application. So basically, we'll have some a scaffold. It will create some scaffold. It will give you a way to test your application from the very beginning. Then we have Langchain, which is the actual library that will interact with the LLM. So from the prompt and from the integration perspective with that LLM, as well as parsing the output of that LLM. And LangSmith, which is one of the newer libraries that the Langchain team has come up, and that's very important because it allows you to do evaluation and monitoring of your application. And then all of this is also powered by a thriving community that has created hundreds of examples, templates, and integrations with different items. And I see there's a couple of questions. Will we get access to the recordings for this session? I do believe so. And I will put that. Cool. So this is, the question is it like no code, low code, but for AI? It does reduce the amount of code that you need to write, but it's not a no-code solution. And I'll show you, and I will show you in a second what it looks like. All right. You can use Langchain either with Python or JavaScript. Those are the officially supported frameworks, but there's also community-supported implementations in Go and Java, among other things. Now, the question being, do we have to set hyperparameters? So Langchain is focused on the creation of the application that uses an LLM, not the training or the creation of the LLM itself. All right. So what is a chain, right? At the end of the day, right? After all, it is Langchain. So we have many individual pieces that work together to create and answer the questions of the user. So we have the user that provides a question, we have a prompt, that may be the question of the user plus additional information we're providing. That gets passed to an LLM, and then the LLM provides a reply. This is a very high level, but at the end of the day, each one of those pieces can get a lot more complex, but at the end of the day, these are the pieces that we're working for. So this is the chain, and thus Langchain. But enough of that, right? Let's take a look at a Langchain and what we can do with it. All right, so hopefully you are all still seeing my screen, and now you're seeing my terminal. And in order to get started with the terminal, we just go Langchain app new, and then we give it a name, and that is going to create a scaffold of our application so we can get started right away. And what that creates for us is this package. Inside of it, we have an app folder where it's created a fast API web service that we can start using right away. So that in here we can start adding routes that will interact with our LLM. It's also created a packages folder where we can automatically import packages that have been created by the community. And there's a lot of those packages, and I'm looking here at the packages that were created, or some of the packages that were created by the community. So there's some that interact with Gemini, some that are doing RAG for Pinecone, and we'll talk about what RAG is for those that don't know. So on and so forth. You can have agents that interact with SQL and SQL databases, etc., etc. And for our purposes, we are going to have, we're going to use this Pirate Speak package. And if we want to use that package, all we have to do is Langchain add Pirate Speak. And that will import it into our solution, and it will make it usable for us. Cool. Let's go back to our application. The other thing that this also provides is Docker file. So you can focus on creating your application. And once you're done, if you want to deploy this as a container to a cloud or in Kubernetes, wherever you want, you can just run this Docker file and create a container, and then you can deploy it, which saves you some time. But let's fast forward somewhat, and let's take a look at this application that I've already created and that already has some packages for us. Okay, so if we go back to our server.py, and the question is, can I get this code? Yes, this is all in GitHub. I will give you the link in a little bit at the end of the presentation. And we can see that I've added some routes to our application, and we're going to take a look at each one of the routes, including the route to our Pirate Speak, which has now been imported into our packages folder. All right. So let's take one last thing I have to say. You can they provide a way to integrate with authentication, which I've commented out this. I just wrote a small authentication version here that will be in the code, but I'm not going to go through it right now. Just keep in mind that it's there when you go through the code. And that code can easily provide authentication for securing your routes. But anyways, so let's start with our first chain. I will come in here and we will look into documentation here, and I'll start with the simple one. And the simple one will be exactly what we saw on the slides, right? It'll be a prompt. We'll ask her to get a question. We'll provide it to OpenAI, and we'll parse the output. Let's take a look at what it would take to build something like that. And this is basically all the code I have to do in order for us to integrate with OpenAI. So I import the chat OpenAI module. I create a template and a parser, a string parser. And in this type, we're going to interact with GPT 3.5 Turbo, and we're going to have our prompt over here, which is basically asking, if you give me a fictional character, please reply with the movies in which that character has been seen or has acted. And you can see here you have an input placeholder. And once we convert this simple string to a chat prompt template, the system will automatically reply or replace that input variable with whatever the user is asking us or providing. And then I create my chain. And the chain looks exactly like what we had on the slide, right? We have a prompt that we defined up here. We have our model, and we have our parser. And for those that are familiar with the Linux and Unix syntax, that's basically a pipe, which means anything that comes as the output of the prompt will be fed into the model automatically, and anything that comes to the model will be fed automatically to the parser. And that's all I have to do. Okay. So now I'm going to start up our application. I'm going to come to my terminal. I'm going to say Langchain app serve. And it's going to start running the application here on port 8000 on my local. So as that gets going, I'm going to come in here, open a new window on my browser, and I say 8000. And this is set up by default to redirect you to the documentation. Now, I didn't write this documentation, right? I didn't create this Open API document or Swagger document. It created it for me for each one of the routes. So the simple route, we have the open router route, and all the routes are created in our application. We get this for free, right? And this gives us a way to invoke our LLM, our chain, whether you want a single invocation, a batch invocation, you want to do streaming, you want to stream the logs or the events, all of this is provided to us and created automatically out of the gate. But more interestingly, it also creates a playground for each one of those endpoints. So I'm going to go /simple/playground. And we can see that it's automatically created a playground for me to start interacting with this LLM. And I can even share this playground so that all people, that for example, if I have somebody that's working on the prompts, so that person can come and play with the prompt and see what happens. So in this case, it's waiting for us to provide them fictional characters. So I'm going to say, Batman, for example, and let's see what movies Batman has been on. And we can see that there's been a number of movies where Batman has been in the big screen. More interesting though, we can see that there's been 3 steps. So for the first step was our prompt template with Batman automatically replaced where we had that input variable. We have the output from OpenAI. So all this is what the response from OpenAI when we send our request. and then the output of the parser. That's actually just taken parse this content and just giving us what we needed. And that's why we ended up at the end. That's why we ended up with this list as the output of our LLM. Now, even though here I'm interacting with OpenAI, switching to interact with another LLM is just as easy, right? So if I wanted to talk to Claude instead, I could say import chat Anthropic. And then I could do chat Anthropic here, and I could start talking with Claude instead of OpenAI. Also, there's a lot of providers that provide access to multiple LLMs, like for example, OpenRouter. And if you haven't heard of OpenRouter, I encourage you to look at it. It has a number of models that you can use. And all I'm going to do, because OpenRouter is using an OpenAI interface or API, I'm going to keep using the chat OpenAI, but instead of just giving the temperature and the model name, I'm also going to give it the URL of where that particular OpenRouter API is located, right? And by doing that, now I can interact with Mixtral 87B. And it will run exactly like we just saw. Very cool. But what about our pirate, right? So we had imported our pirate package. So let's take a look at that instead. All right. So we had our pirate package that's going to reply to us in pirate. So whenever I type something here, hello everyone, and not, it goes and replaces to us ahoy babies, right? And you can tell that this looks different from the other playground that we're using because I configured it slightly different. There's a question about using RAG. We'll get to RAG in a little bit. So I do have an example in RAG. But this is right now, these are very simple implementation, and we're going to build two more complex ones. When you configure the chat to use this version of the chat, it will also put a LangSmith trace here. And that gives us a nice way to take a look at LangSmith. And this is what LangSmith looks like. This is our tracing and monitoring console. And we can see that beyond, some testing that I was doing, we can see the two that we just did. You can see that we ran the simple endpoint with Batman and the pirate endpoint. And if I click on one of them, it gives me the details of what happened, right? So if I click .openai, so we send him this prompt to translate the user input into pirate speak. As a human, we send him hello everyone in the webinar, and this is the response from OpenAI. Right? That's pretty cool. We can see what happened, but more importantly, here we can see when we run that particular query, how long it took, so 0.92 seconds. You can see how much it costs, how many tokens, and the tokens are related to the cost, obviously. So technically, I could go at the end of the webinar and go take a look at how much it costs to run all these examples. But more importantly, in your company, you can keep track of the costs over time. All right. So that's the second example there. Now let's go ahead and take a look at RAG. There was a question about RAG. Well, what is RAG for those that don't know? What RAG means is retrieval augmented generation. And basically, it's a way to allow us to talk to our documents, right? So instead of just using the knowledge of the LLM, we want to use the knowledge that we have in our companies or our personal documents. And it's a two-step process. The first process is taking the documents I want to inspect and talk to, putting it through an embedding model. And this embedding model, what it's going to do is going to take chunks of those documents, small pieces of that document, is going to convert them into a numerical representation. And it's going to take that numerical representation and it's going to store it in a database so we can search through it. And that numerical representation has a semantic meaning of what the document is trying to say. which will allow us to do similarity searches. So that's the step one. Step two is taking a user question and trying to answer that question, right? And so the process in that case is we take the user question, we take that question and convert it into a numerical representation, just like the documents, so that we can take that and do a similarity search in the database. And that will hopefully give us documents that will enable our LLM to answer our question. Now, this is a very simple representation of a RAG chain. So it may work most of the time, but sometimes it doesn't work. That's why I say, hopefully, those documents will have the answer. And then we take those documents and the answer and we put it into a prompt. Right? And then it's the same thing as what we did before. We have a prompt, a model, a parser, and that will allow us to answer a question, hopefully. So let's see how we implement that in Langchain. All right, so I'm not gonna go through the whole document, but I'm gonna pick some highlights. The first thing, we're gonna use the Langchain text loader. And in this case, we're gonna be uploading a Markdown document. I'm gonna split that Markdown document into small chunks. And I'm gonna pass those chunks or pieces to the database, right? So I'm gonna say, Quadrant is the database I'm going to be using. It's a vector database, but you can use any vector database that you want. And I'm going to say, take the document pieces that I have, create some embeddings from them, and store them in the database. Now, like I said, I'm using Quadrant here, but if I wanted to use, for example, a ChromaDB, I could just come here, instead of saying import Quadrant, I would say import Chroma. And that would work exactly the same way. That's what we're doing right now. The last step is to create a retriever. And the whole job of the retriever is, give me a question, and I will look in the database and do a similarity search and return to you the documents that are good to answer this particular question. And that's it. That's our first step. That's the first diagram that we showed. Now, when we want to answer a question, right? The first thing we're gonna have to do is create our chain. So, and our chain looks almost exactly the same as before, right? We have a prompt, a model, and a parser. But now we also add a prompt mapper at the beginning, right? And the prompt mapper is defined up here, and it basically has two things. It has a context, which is going to be fetched by the retriever. So the retriever is going to go and look for these documents, and it's going to have the question that the user is asking. But what is our prompt, right? So I'm going to take this information from the documents and the question. I'm going to pass it to the prompt. But what is our prompt, right? I haven't shown you a prompt here. And that's because I've actually taken the prompt and pulled it down from the Langchain hub prompt. And if we come in here, and we go to LangSmith, there is a prompt hub where you can have prompts that somebody else has created, either public prompts or prompts that created somebody else in my team, or the organization prompts. So you can have either public or private prompts. And in this particular case, we're going to be using this particular prompt that somebody else created for us. And you can see is this prompt is telling us that we're going to retrieve context, and the LLM should reply based on that context, right? And we can see that there's two pieces that are missing here, or the question and the context, which is what our prompt retriever is going to provide. So we go back down here. Our prompt mapper is going to provide that context and the retriever. So let's take a look at that in action, as it is a lot easier to understand once we do it that way. So I'm going to go here, and I'm going to switch for the playground for RAG. And one thing I forgot to mention is that the document that we're going to be using and that we're going to be talking to is this document that I wrote a while back, 4 years ago, when I was teaching Kubernetes at a conference in Wisconsin. So we're gonna say, what year was the CWIT conference? Let's see if he replies. And indeed it was in 2020. So what did he do to get to that answer? Well, let's take a look at LangSmith. And come back here, and you can click on that particular trace. And you can see that the first thing that it did, it was the retriever went to the database and got some information from the database. So these are bits of the document that it found that contain potentially relevant information. Then we put that as part of our input to the LLM. So this is the prompt that we had seen. But now it also has our question, and it also has a context which has those bits of information that we had retrieved, that our retriever had collected, and that contain information not only about the bits of the document, but also what document that's coming from, right? That's coming from that document in particular. So I can tell the user, here's your answer, and here's the document where I got that answer. So that is pretty cool. And then in the end, we just return that information to the user. And you can actually see the raw input that we got, or response that we got from the LLM, and how that was displayed to the user at the end of the day. Cool. So that's RAG, and hopefully that answers that question about RAG. If not, let me know. Let's move on to the next one. So let's talk about agents now. Now, so far we've been just talking to the LLM and it's giving us answers. How about having the LLM interact with the real world, right? So let's imagine we could have an LLM that we want to interact with our a smart thermostat and turn on and turn off the light, for example, right? That's something that we could technically do. But and you do that via an agent and an agent executor. In our particular example, we're going to give our model 3 functions or 3 tools: a multiply function, an add function, and an exponential function. And we're going to ask it to do some math using those 3 functions. But as I said, this could be functions doing anything, right? And then it's going to call one or more of these functions to do some math, and then it's going to give us an answer. So let's take a look at how we can create that agent. So the first thing that we're going to do is we are going to define our tools. So we're going to have multiply, add, and exponentiate. Wow, exponentiate, I don't think that's a real word. That's okay, it's a function name. And then we are going to decorate them with this tool decorator. And this tool decorator is just going to tell Langchain that these functions need to be formatted properly and sent to the LLM so that the LLM can use them. And then we're going to have, once again, we're going to create our chain. We're going to have a prompt, which I'm pulling from Langchain Hub. Then I'm going to tell it, I'll build a small list with all the tools that we can use. And then I'm going to create an OpenAI agent with that information. Now, the agent itself, it doesn't do anything just yet. In order to actually execute the agent, we need an agent executor. And the agent executor, basically what it does is it talks to the LLM, waits to get an answer on which tools it needs to run, runs the tool, then sends information back to the agent, and it does that multiple times, right? As many times as necessary. Now, in the other chains that we were creating, it automatically, the playground automatically knew what we were expecting, what type of input we were expecting. With the agent executor, it doesn't know what input we're expecting. So we're actually going to explicitly say what input type we're looking for. And in this type, we're going to say that we're looking for an agent input. And that's nothing but a class that we defined up here that says we are looking for an input, and it's going to be a string input that this agent executor is expecting. And because we haven't said that it's optional, which we could in the definition, it's going to be mandatory so it's going to be expecting to be there. And then we're going to take the result of the agent, we're going to send it to a Lambda function, and the Lambda function, all it's going to do is going to get the output from the resulting from the result of the call. So let's see if we can get our LLM to do math. So I'm going to come here, and the name of our endpoint is agent. Here, let's say agent, and I'm going to give it a math problem to solve and see what happens. So basically, we're going to say take 3 to the 5th power and multiply that by the sum of 12 and 3. And notice that we're giving it numbers and characters, so it's figuring out what to do all on its own. And that gives a result of 3645, which I think is the right number. But let's see how that worked under the covers. So here's our agent. Right? And I'm going to hide some of the not relevant items so that it's easier to see what happened. So we have our prompt, the question that we're asking, and then we send that to OpenAI. And for OpenAI, we're actually sending, as part of the prompt, the 3 functions that OpenAI can use. And then we're providing, we're telling you're a helpful assistant. Here's the question that the human is asking. And the first thing it's going to reply to us is, I need to exponentiate, wow, that word, hard to say, 3 to the 5th exponent. Right? So it returns that information to our agent executor, and the agent executor runs that, and it gets 243. Then we send that back to OpenAI, and we give it the answer. So for exponentiate, the question you had asked, the answer is 243. What is the next step? And the next step, he says, we need to do some add of 12 and 3. And we can see that it does some add, and some additions. Then we do some multiplications. And finally, after all that, it comes out with the final answer being what we saw on the screen, right? 3645, and it's formatted properly. So this is a back and forth. So OpenAI is not actually running this, right? It's telling us these are the functions that I need you to run, and send me the answer so I can continue to the next step. Well, what about when you have a problem? Let's say, for example, that you are working with OpenAI, and all of a sudden you have a blip on your connection to OpenAI. All of a sudden, your call fails, right? Do you throw an error? That's not the best, user experience, right? So we can have a fallback chain. So, for example, here, first model. If we have an error from that model, whatever the error is, we're going to call a second model and then try to send that, make it work so that the user doesn't realize there was an error. So let's take a look at how we do that in Langchain. So I'm going to come up here, and I have 2 models I'm going to use. GPT 3.5 Turbo from OpenAI, and GPT Fake. GPT Fake, all the rage in Hugging Face, #1 on the leaderboards. no, GPT fake doesn't exist, so it's totally gonna fail. Because that doesn't exist. And then I'm gonna come down here and I'm gonna create a model with a GPT fake, a model with GPT 3.5. And then I'm gonna create a couple of chains. The first chain is gonna be the bad chain that's gonna be using the bad model. The second is gonna be using, this gonna be a chain with the good model. And the third one is gonna be a chain with fallback, right? And the fallback is gonna be our good chain in this case. So let's see how we can do that. And that is on the / multi-chain path here. Multi-chain. All right. And the question that we asked we asked in this particular multi-chain was, why did the animal cross the road? And in that case, we need to provide an animal. The typical joke is why did the chicken cross the road? So we obviously have to put that in there, right? And he replies, yeah, that's a classic joke. It's being very polite about it too. And notice that we didn't notice, as far as where the end user or we are concerned, nothing's happened. We just interacted with our LLM. But if we see under the covers, we can see that there was a not found error because that doesn't exist, right? Then we run the second LLM or the second chain, and we got the proper answer, which is a much better user experience for the end user. All right, so that's the chain with fallback. Now let's come here and let's look at the next one. The next one is routing LLMs. Now let's assume, or actually not assume, it's a fact that running smaller models is significantly cheaper than running the bigger models, right? So we could have, let's say, 3 models trained on specific bodies of knowledge, right? We could have one that's trained in medicine, one in physics, one in chemistry. And then it'd be really cool if we could route, whenever somebody asks a question, we can route it either to one of those 3 models. Or in our case here, we can route it to either, if somebody asks a movies question, we can route it to Star Trek if it's a Star Trek question, or Star Wars if it's a Star Wars question, or to a general chain if it's something completely different. And then one of those 3 models will return the correct answer, right? So let's do that. And what we're going to do here is we're going to create 3 chains. Our first chain, or 4 chains. Our first chain is going to be our routing chain, right? Now, basically, what we're asking it, we're telling it to classify the question that the user is asking, right? It's going to classify on one of those 3 categories. And we're going to keep it, we're going to force it to keep its answer to 2 words because it's either Star Wars, Star Trek, or something else. And that will be the topic of the question. Then we are going to, depending on what that topic is, we're going to have it work with one of the other 3 chains. So we're going to create the Star Trek chain, the Star Wars chain, and the general chain. And we create our final chain at the end of at the bottom, right? So what is this chain going to do? Well, the first thing it's going to do is going to run our classification chain, and it's going to take the classification chain result, which is going to be Star Wars, Star Trek, or something else, and it's going to put it as part of the topic, and then it's going to take the answer that the user provided, and it's going to pass it to our router. And our router, which is defined up here, basically says if the topic is Star Trek, then run Star Trek chain, Star Wars chain, and otherwise the general chain. Cool. Let's see how that works. I'm going to come here to playground, And I don't remember what the path is, so I'm gonna check here. It's route. And come here, we'll say route. And it's asking me for a question, and I'm gonna say, who is Han Solo? And Han Solo is a character from Star Wars, so we should have Star Wars reply. So as Leia says, Han Solo is a scoundrel. Ooh. Also a skilled pilot. Awesome. So how did Langchain arrive to that conclusion? Well, the first thing it did is it called OpenAI, saying you are expert in science fiction movies, where classify this question: who is Han Solo? And the output of that is Star Wars. Right? So that's our topic. And because that's our topic, then it's coming, run the next call to chat OpenAI is to the Star Wars expert, right? Who replies with the correct answer. Very cool. Notice how much easier having LangSmith running makes it to understand what's going on under the hood of these calls. But what did I have to do to set this up so that all that information is captured by LangSmith? Well, I didn't show you any code to hook all this up. That's because the only thing I did was set up these 4 environment variables. And that's all I had to do. That caused that information to immediately be sent to LangSmith for compilation. There's also an SDK if you want to use the SDK instead of using the environment variables. And the good thing about the SDK makes it easy for you to use LangSmith with something else beyond Langchain. So you can use LangSmith pretty much anywhere, which is pretty cool. The other thing that you can see here is that we have a monitor tab that shows us what we've been doing, right? So it gives me the trace count, the number of calls to the LLMs. It gives me success rates. I haven't had a failure today, which is great. The latency, the LLM latency. It even has costs and tokens. It's a lot of information, and it keeps track of this over time, which is important not only for us as developers, but also for the business to keep track of the costs and keep track of the health of the application. The other thing that is really cool here is that we can also use LangSmith to evaluate how good our interactions are with the LLMs. And there are several things that we can do here, right? So let's take, for example, the pirate chain, right? Here's our pirate chain that we have that converts into pirate, and then I can go to the playground, and I can say, instead of translate this into pirate, I can tell it to translate into Klingon, or do anything, right? So if I have an expert on prompt engineering, or if I've seen that for some reason we're getting the wrong answers or getting wrong things coming out of our LLM, we can come in here and start playing with it and actually run it directly from here. And it has a number of parameters that you can tweak so you can get to the right answer, or hopefully the right answer. So you can play with the prompts directly from here. Another really cool thing that you can do here to evaluate your LLMs is that you can send this to an annotation queue. And when you do that, you'll tell me, I'm going to say, I'm going to send it, I could send it to a queue. And when you send it to a queue, basically what happens is, particular one, this is actually a queue that I set up for evaluating our animals endpoint. You can see the question data, the output, and I can have somebody coming here and say, oh, I think this is not correct. For example, I can add additional tags. I can put a comment here. Whoa, not good. And then I keep it done. And then that annotation remains with that particular run. So people can come and review those annotations and review why the human thinks that something went right or something went wrong. And that's very important when you're trying to understand how your application is behaving. The other thing that you can do is instead of sending something to an annotation queue, you can also send it to a data set. And in here, I have a data set that has, to which I've sent 5 runs. So it has all, and this is I've been running this before this call, obviously. But for example, I had a run for Aquaman, and basically what I'm telling the LangSmith here is, whenever somebody runs with an input of Aquaman, I want this to be your golden answer, right? I want you to compare additional runs of this particular LLM calls to this answer and see how well or poorly those answers are in comparison to this one. And then I can run a number of experiments, right? You can see a number of runs I've done here. For example, number 16 gives me, for each one of my examples, I have the output of, or my golden output, and then I have the output of that particular run. And it will give me, and it will evaluate that against a number of measures. For example, this is contextual accuracy. And in this particular case, you give me, this is the original answer, this is the answer from this particular run. And it gives me that it believes, right, from those 2 runs, it believes that this was a correct representation, right? And that's because the student answer lists all the movies mentioned in the context, right? So even though these don't look anything alike, right? They're written differently, but they semantically are saying the same thing. So it believes that this is contextually correct. Right? But how do you, the next question is probably, well, so how do I create my own experiments, my own runs? Right? So I'm going to click here, new experiment. And basically I want to run for correctness. Oops, I want to run for relevance and coherence, for example. And it gives me an explanation of what each one of those mean. And on the right-hand side, it basically created all the code that I need to run this and to evaluate and to create new experiments. So I can take that code, copy it into a module here, which I created here already for us. So this is an evaluation. So I basically I copied and pasted that code. I modified it slightly to use the LLM that I wanted to use. And then I pasted the evaluators. So in this case, we're going to be running for relevance and insensitivity. And I could even create my own custom evaluators if I wanted to. Yeah. Now I'm going to say run 17. And I'm going to run it for 5 times. So I'm going to come here, and save this. Then I can come here, and I can just come here and say Python evaluation, and I'm basically running that Python script. And it's going to go and it starts running this through the LLMs 5 times. So you can see here it's going to start counting 1, 2, 3, 4, 5 while it's running all that. And while that's running, let's take a look over here. We can see that it started running. We can see that my previous runs, I have a number of charts that show my previous runs, how good or bad they were doing. You can also see, the latency of each one of those runs, error rate, prompt tokens, etc. And I can even compare the runs, and I can see that our run hasn't finished just yet, but I can compare to previous runs, and it will give me some graphs and additional information about each one of those runs. So here, for example, I can see that one took a whole second longer than the other, and I can start looking into that and why that's happening. And I see there's some questions. How do we clean the codes? Will be required to check and clean it on regular intervals. I'm not sure what that question means. So whoever wrote that question, how do we clean the codes? If you could provide additional information, I'd be happy to answer. What are the security layers? In this case, I'm assuming you're talking about in terms of authentication, right? So in server PY, you can see that I've added. This is a simple token verification middleware that's provided by that's already built in from LangSmith. You can also authenticate with OAuth or other type of authentication that you want. Right. Quickly, just to finish up, since we're running out of time, keep in mind that Langchain is changing fast because AI is changing fast. So a lot of third-party tutorials are already working with deprecated code. So always go back to the official documentation and official blog posts to check the latest information, which is very important. Keeping up with AI is always a little bit of a challenge. It changes so quickly. And also keep in mind that LLMs have inherent issues, right? Issues like hallucinations, prompt fragility. Langchain will not fix those for you, right? It's not fixing, but it will. But using LangSmith can help you evaluate your application, evaluate how those LLMs are working for you, and minimize those issues, and actually help you keep the health of your application. Beyond that, I will provide these useful resources that have all the different pieces that we use for our blog, for our webinar. And with that, I'm open to any additional questions that anybody may have. And there was a question about the repo. This is the repo that we were using, where all the code is for what we discussed just now.
I think we have one more question. It's in the Q&A box.
Oh, yeah, okay. I need to scroll a little bit more, huh? All right. If we face bugs or an error, will we get an update? The Langchain team has a Discord channel where you can go and join and ask your questions. There also, all of Langchain is open source. So you can go to GitHub, just look for Langchain on GitHub, and you can put your questions and bugs, and they're pretty responsive. I'm trying to build an in-house solution for OpenAI advanced analysis tools, previous called code interpreter. What kind of agent combination will allow Python codes in the background to send an image to the front end? You can use Langchain to interact with OpenAI in their vision model and their image models. I would have to have a little more details on exactly what you're trying to do, but yes, you can definitely do interact with images in Langchain. Any additional questions?
Someone has asked what all one needs to know before building an LLM, what all concepts should be clear.
Before building an LLM, well, there's two things. There's building the LLM itself, right? So you need to, for that, you need to know about machine learning. You need to know about training a model. And there's a lot of data science and machine learning science behind that. There's a lot of machine learning information on the web, and there's a lot of places where you can learn about that. That's a big topic on itself. And then there is the creation of applications that use the LLM, which is what we did here, right? So those are two different topics, and they're both very big topics, and they're both changing very quickly. One good place that I would say that you can go and take a look at classes that I really like is deep learning .ai. They have both short courses and specializations, and in the specialization you have specializations for machine learning, and I think they are working with other providers for like Coursera for the classes themselves, which is pretty cool. What all concepts should we clear before trying to build? The main concept, the most important thing to keep in mind when you're working with LLMs is that they're not predictable, right? You may ask a question 100 times and get 100 different answers, not necessarily wrong answers, but semantically similar answers, but written in completely different ways. And they may also have hallucinations, in which point they're very confidently just lying to you. So it's very important that you understand that that's the case, and that you keep that in mind when you're building your application, so that you are providing the correct information to your users. There was a case in Canada Air, the airline from Canada, where their bot gave the wrong information in a chat to one of the person that was traveling, and that went to court because they got sued. And the court said, yes, your bot said that this is the truth, so you have to make right, and they were forced to actually accept that. So it's important to understand that the LLMs are not perfect. Next question, is it better to pipeline an LLM? And by pipeline, I'm assuming you are talking about doing DevOps and building a pipeline to deploy your LLM. Yeah, absolutely. Right. DevOps is a great way to keep your application up to date and building a pipeline to make sure that your application you can deploy changes to your application quickly, especially at the beginning, right? Because you're going to be playing with prompts, and you're going to be making sure that the application is working properly. So you're going to have to iterate quickly, and without a pipeline, that becomes cumbersome.
Great. I think those are all the questions we have for now. So a heartfelt thank you to you, Juan, for this insightful session, and a big round of applause for everyone who joined today and participated so actively. But before we leave, we are eager to hear your feedback on today's session. Please take a moment to fill out our quick NPS survey. Your responses are incredibly valuable to us, and they will help us improve our future webinars. So I'll be running the poll now. You will get the poll now. So while you fill the poll, let me give you an introduction to what we do at E2E Networks. E2E Networks Limited is the leading AI-first hyperscaler from India, focusing on providing advanced cloud GPU infrastructure. We lead the industry as prominent cloud GPU providers, offering a comprehensive range of NVIDIA GPUs, including the HGX H100, A100, L40S, L4, A40, V100, and T4s. To know more about us, you can check out our website, e2enetworks.com, or if you want to get your hands on one of our GPUs, you can sign up at My Account www.e2enetworks.com. So thank you, everyone. We are also having another webinar on generative AI and marketing on 7th of May with Debashri Rakshit, the co-founder of superteams.ai. You'll receive an email with a recording of this session along with a link to register. That's all from us today at E2E Networks Limited, and we hope you found this webinar valuable. Stay tuned for more such events and have a wonderful day ahead. Thank you so much, Juan, for being there and for taking out the time for this webinar. Bye.